Greetings to dear students. So we are going to continue the problems regarding residue of the function at the point. Okay. So the second problem is find the residue at z equal to 0 of 1 plus e power z by z cos z plus sin z. Okay. Here they have given the point. Um, where we are going to find the residue. They have given the point at z equal to 0 only we are going to find the residue. Okay, so for what function? This function 1 plus e power z by z cos z plus sin z. So we have taken this function as f of z. Okay, so f of z is equal to 1 plus e power z by z cos z plus sin z. Okay, so here if note that uh, it 0 is a pole for this function f of z of order 1. Why? When you substitute 0 here, is a 0 into cos 0, 0 plus sin 0, 0. So this will become 0. So therefore, the analytic fails at the point z equal to 0 and is a simple pole and moreover it is a simple pole. Okay, so 0 is a pole for f of z of order 1. Okay, so residue of f of z at the point 0. Residue of f of z at the point 0. Here, you cannot apply the first formula and you cannot apply the second formula. What is the first formula? Limit z tends to a z minus a into f of z. So here z minus a, we have z minus 0, but not in separate term. In a multiplication way only, we are having z minus 0. So we cannot apply the first formula. Same as we cannot apply the second formula. Okay, so we should go with the third formula only. So therefore, residue of f of z at the point 0 is equal to h of 0 by k dash of 0, where h of z is the terms in the numerator and k of z is the terms in the denominator. So h of z equal to 1 plus e power z and k of z is equal to z cos z plus sin z. What are the things we need to check? H of 0 should be not equal to 0 and k of 0 must be 0. So first let us find the value of h of 0. H of 0 is equal to 1 plus e power 0, e power 0, 1. So it is equal to 2, not equal to 0. K of 0, clearly k of 0 is equal to 0. So to find the residue at the point, we need h dash of z. So therefore, we are finding the h dash of z. So h dash of z is equal to, here we have two terms, z and cos z. So we are applying UV method, okay, because these two terms have the variable z. So what is UV method? UV dash is equal to UV dash plus VU dash. First we fix the term U and differentiating the second term. Plus by fixing the second term, we're differentiating the first term. So first Z, and we Z will remain as Z, and we differentiate cos Z, it will become sin. And we differentiate cos Z, it will become minus sin Z plus sin Z. Yeah, sin Z. Okay, what happened? Okay, so Z will remain and differentiating cos Z is equal to minus sin Z plus VU dash. What is V here? Cos Z. When we differentiate Z, it will become 1. So cos Z we get. Plus sin Z only we have here. Differentiation of sin Z is cos Z. Therefore, H dash of, sorry, K dash of Z is equal to this one. So now substitute the point 0 in the place of z, we get k dash of 0 is equal to 0 0 into minus sin 0 0, so the first term will become 0, second term cos 0, cos 0 is equal to 1, third term again cos 0 is equal to 1, so it is equal to 2. So therefore h of 0 is 2 and k dash of 0 is also 2. So therefore h of 0 by k dash of 0 is equal to 2 by 2, which is equal to 1. So therefore residue of the function f of z at the point z equal to 0 is 2. Okay. So next problem, find the residue of 1 by z square plus a square the whole square at the point z equal to ai. Here they have mentioned the point in where we have to find the residue. So they have given the point as z equal to ai. Okay, z equal to ai. So let us take the given function as f of z. F of z is equal to 1 by z square plus a square into z. Note that z square plus a square, okay, z square plus a square can be rewrite as z plus ai into z minus ai. We have the whole square. Now, we know that ab, the whole square is equal to a square into b square. The same apply here. We get z plus ai the whole square into z minus ai the whole square. So what are the poles for the given function f of z? Ai and minus ai. But they are not simple pole. Okay, they are poles of order 2. Ai is a pole of order 2. Similarly, minus ai is also a pole of order 2. But they are asked to find the residue at the point z equal to ai only. Okay. So residue of f of z at the point ai. Okay. Here ai is a pole of order greater than 1. So which formula we have to apply here? Which formula? If f of z is equal to some g of z by z minus a the whole power m, then the residue value is g power m minus 1 of a by m minus 1 factorial. Okay, so this formula only we are going to apply. So the denominator part, it be of the form, should be of the form z minus a the whole power m. Okay, so how we are choosing the g of z? Okay, we are going to find the residue at ai. So the remaining thing will be g of z. So g of z is 1 by z plus ai the whole square. G of z is 1 by z plus ai the whole square. So here, since it is a pole of order 2, by the definition, if it's pole of order m, then we have to differentiate m minus 1 times. Since it is a pole of order 2, we have to differentiate only 1 times. So what is the residue formula? G dash of ai by 1 factorial. So g of z is 1 by z plus ai the whole square. We are going to find the differentiation g dash of z. So g of z can be written as z plus ai power minus 2. So by differentiation formula, we have g dash of z equal to minus 2 into z plus ai the whole power minus 2 plus 1, that is minus 3. When we differentiate z, we will get 1. So therefore, g dash of z is equal to minus 2 into z plus ai the whole power minus 3, which is equal to minus 2 by z plus ai the whole power minus 3. Sorry, whole power 3. Now we are going to apply the value ai because we need g dash of ai. We need g dash of ai. Okay. So therefore, g dash of ai is equal to, okay, therefore, a residue of f of at the point ai is equal to g dash of ai, which is equal to minus 2 by g dash of z is equal to this. We are applying the value ai in the place z. So minus 2 by ai plus ai 2ai the whole cube. So 2 cube is equal to 8, a cube I cube. I cube is I square into I cube can be written as I square into I square into I square, the value of I square is -1 into I only. So minus I. Since the I shouldn't come in the denominator part, we are multiply and divide by I again. So we get when simplifying this, we get 1 by 4 a cube I. Since the I shouldn't come in the denominator part, we have to multiply and divide by I. So the numerator will become I, the denominator I square, which is equal to -1. So therefore, residue of f of x at the point a I is minus I by 4a cube. Okay, so in this place, we cannot apply the first formula and second formula. We must go with the third only. Okay, so in this situation, so according to the situation, we have to wisely use the formula. Okay, sorry, since this is the it's a pole of water greater than 1, we must go with one. We have only one formula for pole of water greater than 1, so we should go with that one. In the previous one, they must go with the third formula because it does not have the term z minus a in the denominator part. Okay. Okay. So according to the problem given, you have to choose wisely whether you have to use the first formula, second formula, or third formula. Okay. So thank you, dear students. We will see the remaining problem in the upcoming videos. Okay. Thank you.